So greetings everybody and welcome back. This is the second installment of the Games Beyond Entertainment track for FDG 2020. We have 4 papers today, and as you already know, since you've been in other sessions probably, papers vary between a full paper of 15 minutes and a short paper of 10 minutes. Now, not many of the authors check the chat, so in case you go over time, and I'm speaking to the ones who are presenting live, I will interject and ask you to conclude very quickly. There's not much time for questions and answers, so normally it's about 2 to 3 minutes at the end of each presentation. As Rogerio already hinted at, the conversation can continue either in the chat or in the Discord channel for the FDG conference. With the help of Phil or Rogerio, launched the first talk, which we didn't get to see. Let me repeat, it's called The Effect of Timer, Top Score and Leaderboard Performance and Motivation in a Human Computing Game, and it was presented, or rather written, by 4 different authors from the University of Manitoba, Canada. Let's see if we can get it to run this time.
Okay, let me know if you can hear the video this time.
Hello everyone, I'm Rogerio and I'm going to present the paper Effect of Timer, Top Score and Leaderboard on Performance and Motivation in a Human Computing Game.
Can you hear that?
Yes, we could, at least I could.
Okay, so I will keep going.
Hello everyone, I'm Rogerio and I'm going to present the paper Effect of Timer, Top Score and Leaderboard on Performance and Motivation in a Human Computing Game. There's an increasingly high number of crowdsourced systems adopting gamification or even games to attract more volunteers. This strategy is good, but there is a catch. The game needs to be interesting enough to attract and retain a large enough player base. Finding the right balance between accurate data collection and a fun game experience is an extremely difficult task. One way to make human computing games more captivating is for them to emulate commercial video games by incorporating several game mechanics, such as score systems, timers, and leaderboards. However, it's not clear how efficient these game features are at keeping the players interested and motivated in the game, and if they can potentially interfere with the quality of the solutions produced. Our research started with a problem in comparative genomes called the genome sorting problem. In the genome sorting problem, we are interested to find the smallest evolutionary distance between 2 genomes. That means, how many evolutionary events do you need to transform one genome into another? A genome can be represented as a string of characters, and a genome sorting problem can be simplified as a string matching problem. At first, the problem seems simple, but it is classified as an NP-hard problem when you have genomes with duplicate genes, and that happens almost all of the time. We abstracted this problem as a puzzle and we created G-Sort, a game where the players have fun solving this puzzle and generate useful data. In this study, we added some new mechanics in G-Sort to investigate if they can contribute to the player's motivation and if they would interfere with the data quality. In this study, we aim to answer these research questions. What's the effect of setting a time limit for each puzzle using a timer? What's the effect of showing the top score? What's the effect of showing the leaderboard coupled with the context-dependent point system? How will these 3 different game mechanics interact together? In this study, we have 2 dependent variables, score and completion time. The score is the number of moves used to solve the puzzle, and the completion time is the amount of time used to solve the puzzle. This will become clear when we explain how the game works. G-Sort is a puzzle matching game, in which we have 2 rows of colored shapes, and the goal is to transform the mutable row and the target row through 3 different operations: duplications, deletions, and inversions. Each row represents a genome, or a gene order, and each colored shape represents one gene. The three operations represent common observed evolutionary events that can transform a genome through the evolution. We know that the human brain is very good to recognize patterns, so the G-Sort's goal is to compare the sequence of moves used by players to solve the puzzle. The player starts the level with score 0. Every time the player performs an operation, also called move, their score is increased by 1. The goal is to solve the puzzle with fewer moves as possible. We used a 2-qubit mixed factorial design, with 2 within subject factors, top score and leaderboard, and 1 between subject factor, timer, which can all be either on or off. The timer was chosen to be the between subject factor to avoid a potentially pervasive effect where players being introduced to a timer would think that they always need to complete the level as quick as possible, even when it was not there anymore. 24 participants were recruited in total to play the game individually. Half of them play with the timer present all the time, and the other half without it. All participants played all the 4 different combinations of the top score and leaderboard. Every participant answered a short demographic questionnaire and completed an in-game tutorial before starting the experiment. Each game session, one for each condition, contained 6 different levels of increasing difficulty. The 4 conditions were played in different orders by the participants to avoid sequence effects. Moreover, the puzzles were shuffled between participants to ensure that the same puzzle was not always associated with the same game condition. After playing each game session, a short interview was conducted to get the player's opinion on the last game condition played. A long interview was conducted at the very end of the experiment to get the player's overall opinion of the game, the different conditions, and the 3 game mechanics studied. In this study, we added 3 common commercial game mechanics: timer, top score, and leaderboard. Each level, the player had limited amount of time to solve the puzzle, transforming the mutable row in the target row. If the time ends, the player needed to restart the level. Top score represents the best score achieved by a player on the level. In this context, lowest is better. In this study, we set the top score for each level to the number of events that were used to generate the puzzle plus 1. This was done to simulate a real top score, which would leave some room for improvement. The live leaderboard shows the player's position against other 9 simulated players. Points were assigned to simulated players in such a way that each real participant could potentially reach the top of the leaderboard during the game session. The player's position was updated at the end of each completed level. Players were rewarded with points after finishing the level. The points were calculated based on the time remaining when the time is present, and the difference between the score and top score when the top score is present. We first look at the average score per level. Recall that the score represents the total number of moves made to complete the level. Hence, lower scores represent better performance. Clearly, mean scores are lower when the time is off, and the lowest mean, 5.77, is obtained in the top score on, leaderboard on condition. This can be explained by the fact that the top score gives the players an idea of what an achievable score can be, and the combination of the point system with the leaderboard further encourages players to achieve a lower score. On the other hand, the highest mean score, 7.47, occurred when the timer was on, in the top score off, leaderboard on condition. Players trying to complete the level faster to get more points, coupled with the absence of the top score in this condition, probably encourage the players to complete the level as quick as possible without as much consideration for the number of moves they were using. We also look at the average completion time per level. We can clearly observe that the average completion time were considerably lower whenever the time was present. The variability of completion time is also much higher when the time is absent, as demonstrated by the standard deviation, which are approximately twice as large compared with the ons of the timer on group. Mean completion times are very similar between all 4 possible conditions when the time is present. However, the completion times are significantly higher when the top score is on and the time is off, which indicates that the players are taking more time in those conditions as they try to reach or beat the top score. A mixed factorial ANOVA was performed to check for main effects and interactions on the 3 factor studies. on players' score and completion time. The analysis detected a main effect of the timer and the top score on both scores and completion times. However, no significant main effect of the leaderboard was detected on the two dependent variables. We looked in the simple effect of timer on both the score and completion time. It turns out that the timer has significant effect on the score only when the leaderboard is present, whereas the timer has significant effect on each of the four conditions for the completion time. We observed interesting interaction between the studied game features. The lowest average score are obtained when the timer is off and both the leaderboard and the top score are on. On the other hand, some of the highest average scores are obtained when both the timer and the leaderboard are on and the top score is off. In other words, the point system that comes with the leaderboard seems to encourage players to make more moves in presence of the timer, which is probably a consequence of players just trying to complete the level as fast as possible. On the completion time perspective, the players tend to spend more time on the level whenever the top score is on and the time is off. In this study, we observed interesting effects of timer and top score. Giving the players an idea of an ideal number of moves influences players to spend more time solving the puzzle and produce solutions with fewer moves. One important detail about the game is that sub-option solutions to the puzzles are easier to find than option solutions. When the time is present, players seem to take the easier road to solve the puzzles quicker, but using more moves. Some players like the added challenge and excitement provided by timer, top score, and leaderboard, while others dislike the added pressure and wanted a more relaxing game experience. The only thing that was constant across all the participants was that they preferred to have at least one of these conditions presented all the time. Based on our study, some lessons can be drawn for designing a human computing game. From a player's motivation perspective, it might be beneficial to implement multiple game features and automatically alternate between the different game modes to keep different types of players motivated. Another option could be to let the players choose which game mode they want to play. From a data acquisition point of view, timers should be implemented when a large number of solutions are necessary in a short amount of time, but they should be avoided when the task is very hard or when top quality solutions are required. On the other hand, presenting a top score is beneficial to guide the players towards higher quality solutions, but it can also be frustrating if it's too hard to reach. To mitigate this, human computing game designers should consider allowing the player to advance to the next level if the top score was not reached, and or retiring puzzles when the top score seems unbeatable. The goal of this study was to investigate the effect of different game mechanics, timer, top score, and live leaderboards on players' performance and motivation in a human computing game. We observed that the timer and the top score had significant effects on players' score and completion time. Presenting an achievable top score resulted in more optimal solutions, but at the expense of completion time, whereas the timer had the opposite effect on players. Our findings tend to suggest that customizable of the game interface or letting players choose between different game modes might be preferable to promote players' motivation in a human computing game. Our findings still left important questions unanswered. One of them is what motivates users to participate in and stay engaged with human computing, crowdsourcing, and citizen science applications in general. Human computing, crowdsourcing, and citizen science platforms should not only be focused on companies or scientists collecting data. They must also be concerned about citizens actively participating in problem solving, collaborating with other participants, and learning something valuable from the experience. Studying how to properly give back to the users, how to improve learning outcomes from participants in these platforms, how to promote collaborative work, all are crucial questions that need to be answered in future works. Thank you.
Thank you. Fascinating stuff. Great stuff. Finally, we got to see it. Do we have questions about this presentation? Phil is clapping. A lot of people are clapping. I found it really interesting. I wonder how if it would have worked differently with a different style of game, because you're kind of, what do you call it? Popular science game relied on very well-known casual game tropes. If you distance yourself from the casual game, say, set of guidelines, would you get similar results, you think?
I'm sorry, I was reading the chat. I was not paying attention to the question.
Doesn't matter. I was just wondering whether do you think you would have gotten the same results had you done popular science with a game that was not similar to a casual game? So if you had like other traits like longer play sessions, more complicated mechanics, would you have obtained the same results, you think?
That is a really good question, and we are working on a study to answer this question right now, and we're going to submit it tomorrow for HCI. So I cannot answer you right now, but I can answer you as soon as they accept it, I hope.
All right. Do we have any other questions, maybe some that can be answered directly? No, I don't see any. So I want to thank you once again for sticking to this track and for your patience and with all the little technical problems we've had. Rogerio, you've been like so nice to stick with us and to do it again and to answer all our questions. I think we should move on to Edward Meltzer. Are you here, Edward?
Yeah, I am.
According to my records here, you're presenting live. You have a full paper of 15 minutes. Titled Getting Academical, a choice-based interactive storytelling game for teaching responsible conduct of research. And you have developed this work in collaboration with a number of different authors from UC Santa Cruz. If you wouldn't mind, please take the floor and enlighten us on how to do research through games.
Sure. Okay, let me share my screen. Can everyone see that okay? Okay, good. All right, well, let me just go ahead and present. There we go. Okay, so this is, oh, let me just move all the people. Okay. So this is our paper, Getting Academical, Choice-Based Interactive Storytelling Game for Teaching Responsible Conduct of Research. This is work that was done with myself and my postdoc at the Alt Games Lab in collaboration with a bunch of current members and alum from the Expressive Intelligence Studio over at UC Santa Cruz, and Brent Hill over at University of Utah, who was kind enough to lend us their responsible conduct of teaching, responsible conduct of research web tool. So I'll just start by saying that responsible conduct of research is a pretty crucial skill for researchers. I think everyone here is pretty familiar with that. Most of these ones on the left are very well-known publicized studies, the Stanford prison experiments, where they locked people in a prison and had them pretend to be guards or prisoners. The Milgram shock experiments, where they had someone pretend they were getting shocked and under mental distress. And all sorts of Maslow work with animals that was pretty much torturing them, and things where we do innocent bystander things, where someone fakes being in distress. And so these are some really famous classical examples that have been criticized for being really unethical. And unfortunately, even today, I think there's a lot of examples that responsible conduct of research is still desperately needed. I think a lot of folks remember Facebook's experiment purposely manipulating users' emotions without them knowing. There's always going to be battles about protecting user data with relation to artificial intelligence and data mining. And so understanding how to be responsible in how you conduct research is quite important. The other important thing to think about with teaching RCR is it's actually really difficult. It's not just knowledge skills. You're actually trying to teach applied ethics and ethical decision-making that actually require you to understand a variety of perspectives and dilemmas that can impact research ethics. And also that a lot of the current RCR training tools suffer from a notable lack of user engagement and motivation. Here's a pretty good example of one of the standard ones we use in the US, which is perhaps not the most engaging presentation of RCR material, to just have to sit there and read it in a text-based block. So we thought about what if we created a choice-based interactive storytelling game to improve engagement with, knowledge of, and more reasoning skills for the responsible conduct of research. And so that sort of led to the design of this game that we call Academical. It's an interactive storytelling game using the Twine authoring framework. It's choice-based, so it's focusing on allowing players to perform moral reasoning and ethical decision-making during gameplay. It provides 9 unique scenarios, each sort of covering a different RCR topic that's been highlighted by the NIH and SF as core topics. So conflict of interest, human and animal subjects, mentoring, collaboration, peer review, data management, misconduct, authorship and publication, and scientists and their contributions to society. Notably, in this game, one of the key things that we really focus on is that you don't play through a scenario once or go through a narrative once, you actually play through it multiple times from the perspective of different characters or stakeholders in the RCR activity. And the game also really focuses on sort of employing this complexity and uncertainty in your choices to evoke questions around how different courses of action could have, unexpected consequences. So just to kind of illustrate this is an a scenario from Academical. This is actually the first level in the game, which is focusing on IRB approval. And so it's called Head Start. And as you can see, you can actually pick to play as either the advisor or the graduate student. And when you play, the game will actually start by sort of giving you some background context for the role that you're playing, the scenario, and what they're trying to achieve. So in this case, he's frustrated because the IRB hasn't gotten back to them in a month. Then you get to make different choices on how you interact with the other character. And eventually you'll come to a good or bad scenario. And scenarios can actually kind of be gray areas. So this is a good scenario because the advisor actually told the student, hey, we can't run test subjects before getting IRB approval. But maybe not the most ideal because it actually tells you in the game that he doesn't know IRB that well, hasn't been trained. And so a better choice would have been to actually send the student to the IRB office to ask these questions. And so there are kind of okay scenario endings, and then there are good scenario endings and bad scenario endings. You can kind of see all the different ones. But since you've successfully completed the advisor perspective, you get to go back and play as a grad student and get to see, the pressure of not wanting to do work over the summer, all sorts of other things that are kind of pushing into feeling like you're forced to do this work. And so then you basically get to make these decisions again to the scenario from the perspective of the grad student. And you can end with bad endings, like basically deciding to run experiments with human subjects without getting IRB approval. So based on this and the design of Academical and what we covered, we actually kind of came up with 3 major hypotheses about the game. That one, it would be more engaging for learners than traditional RCR materials like those web-based reading ones. It would be as effective as traditional RCR educational materials for just developing the knowledge. And it would probably result in stronger moral reasoning skills because you're actually participating in ethical decision-making to play the game. So to test this, we conducted a between subjects study. So we had one group of people sit and do the Utah web training game. We had another group of people sit and play the Academical game. And they each played 2 different modules or scenarios from it, focusing on authorship and peer review. And we basically measured their engagement using the Temple Presence Inventory, which is a validated tool to measure engagement, their RCR knowledge, So we actually took the quizzes from the RCR course from the University of Utah that we were training one group on and quizzed both of them to assess their knowledge at the end. And then we did moral reasoning skills. And so we asked them open-ended questions about 2 different RCR short stories that we gave them, obtained from the Online Ethics Center for Engineering. And we had them answer some short questions that assessed their ability to analyze different aspects of moral reasoning and perform different moral reasoning skills. So could you analyze the moral problem? Could you consider the viewpoints of all the people involved? And could you propose successful solutions and understand the implications of that in the short and long term? And then we actually used and scored that qualitative responses using a behaviorally anchored rating scale, which has been used in past methods. And so we ran this study with 28 university graduate and undergraduate students. The web materials condition had 14. The academical game condition had 14, and none of them had reported any prior RCR training within recent years. And there was no significant difference between any of the participants with respect to their age, prior gaming experience, or interactive story experience. So we could kind of assume that these are roughly the same populations. And so when we actually ran this and conducted the study, we got some really promising results. First, we saw that there was a significant improvement in engagement, which basically we were expecting that. Usually a game-based approach is more effective in being entertaining and engaging. So it was nice to see those results validated. That for RCR knowledge, it was significantly better for learning on the peer review test, and there were no significant better or worse differences on the authorship test. So it seems that this interactive story approach is as effective or more effective, depending on the material. And finally, for the moral reasoning, and this is kind of the really exciting results, the academical group actually scored way higher on each of those individual scales. So people who played the game were able to identify issues better, describe those viewpoints better of the different RCR stakeholders, and actually propose, better solutions. And then overall, their total score for, the combined moral reasoning was also significant. So it seems that this type of moral reasoning choice-based approach to it is really, really effective. And so basically, all of these results sort of fall in line with existing literature and expand it to sort of these ambiguous content and more like ethically complex content, which hasn't been as explored as much in the educational games literature. Particularly interesting is that for moral reasoning, most tools struggle in the sense that they can either teach RCR knowledge, but when they do, they actually aren't shown to be very effective at teaching moral reasoning. And so academical is actually now shown to be effective at both. So it provides a pretty marked improvement over existing RCR training tools. And so basically based on these promising results, there's a whole lot of other things we want to look at: character attachment, situational interest of the interface and the graphics on learning outcomes, how the game can improve attitudes and anticipated behavior towards responsible conduct of research, all sorts of things like that. And so basically, just to conclude, a choice-based interactive storytelling game design is effective as an RCR training tool. And we found that learners develop significantly higher engagement, stronger overall moral reasoning skills, and better knowledge scores for certain RCR topics, which really makes interactive storytelling quite a promising method for teaching like morally complex topics. That's it. Thank you.
Many thanks, Edward. Before we move on to question and answers, I've been in touch with the conference chairs, and they managed to solve Rogerio's problem, and they suggested the following course of action. We will run Rogerio's video at the end of this session, meaning that whoever is interested in his exceptional paper, actually is one of the best rated paper in the entire conference, can stay at the end of the current section. Rogerio, I hope this is an acceptable solution for you. please let me know in the chat while we ask Edward questions concerning his paper about getting academical and having made a game to teach us ethics and proper behavior in research as a postgrad student. Do we have any takers? Alessia comments in the chat, but I think it's just a comment and not a question. Does anybody have any interrogatives about the presentation? Of course, without having read the paper.
I see a question from Denise in the chat.
I don't see it, but Denise, please unmute yourself and ask the question.
I just wanted to know if you did the whole thing in Twine or if you had to use, like, you know, Unity. Did you take it to a different game engine?
Yeah, we used it all in Twine because it's web-based and that's probably more ideal for that. We have run into some issues that we did it in, you know, Twine 1 and now Twine 2 is the thing. So there's definitely some portability and keeping it updated issues, but yeah, it was all done in Twine.
We have time for one more short question before we move on to Lindsay and his. Any takers? I'm interested in the role of the independent game designer Squinky in the whole process because I've known her for other productions and I was wondering how you involved the, let's call it, professional independent developer in an academic situation. Can you comment on that?
A little bit. So Swinky was actually a member of the Expressive Intelligence Studio, so not my lab, and was there before I was on this project. But I believe they did this as part of their master's work before they graduated.
I see.
Yeah.
Okay. Thank you very much for being terse and clear throughout. We need to move on for the sake of time to the third paper in this section, which is another full paper, 15 minutes with Awkward Annie. Impacts on playing on the edge of social norms. The presenter here is Lindsay Grace, professor at Miami University. And if I'm not mistaken, this was a collaboration between the American Education Testing Service and your university. Please take the floor, Lindsay.
Great, thank you, Stefano. I'm gonna go ahead and share screen now. Just make sure you guys can see that. Slides okay? Great, all right, and it's also subtitled for anyone in case I speak too quickly or you're hearing impaired. All right, so real quickly, this is Awkward Annie, Impacts of Playing on the Edge of Social Norms. Hi from Miami. So I'm Lindsay Grace, Knight Chair in Interactive Media at the University of Miami. You can learn more about me at professorgrace.com. And the collaborators were Blair Lehman at ETS, the Educational Testing Service, and Dr. G. Tanner Jackson. So Dr. Blair Lehman and Dr. G. Tanner Jackson. So basically, we are interested in problems around pragmatics assessment. If you're unfamiliar with pragmatics, in short, that's knowing what to say to whom and under what circumstances. So the two areas that we were most interested in were socio-pragmatic assessment, which is basically assessing someone's ability to read a context or social hierarchy in order to communicate effectively and read communications effectively. And then pragmalinguistics, which is more focused on how they say. So think of the first as the sort of like the context and the second and how it's delivered. So here's an example I actually think is kind of a charming example of complex sociopragmatics and pragmalinguistics. Little text message about someone eating cereal in bed. I think you can read it from there, but it's sort of funny that one person is just really insistent on the cereal instead of recognizing that there's a bit of a flirt going on there. And these are the kind of things that when you master a language, we want to be able to assess to make sure that you're reading the communication appropriately. So sociopragmatics and pragmalinguistics are also useful as we look at sort of a growing cross-cultural communication world and an interdisciplinary world. So as people from different cultures continue to communicate with each other, as we've seen last decade plus, essentially what we want to do is be able to assess that, especially in a professional world, to make sure that people aren't offended one way or the other, or that they're clearly communicating their intention. And typically this kind of assessment of interpersonal communication occurs, say in the international workplace, it occurs via interviews. And so these one-on-one interviews are typically scored and graded. And the problem, of course, is that they're expensive and time-consuming as an assessment. One-on-one interviews mean that if you're doing 40, 50 people, it's a lot of work hours. And so we developed a tool to assess language pragmatics. And we did that with this Awkward Annie tool. This is a quick video. I think the frame rate will be fine for you. Just kind of demonstrates how the game works. So you navigate Annie, which is the character here, have your random sort of conversations. This first level is really just explanation and assessment of people's ability to use the tool itself. We generated this originally very quickly and then refined it over a long time to meet the very specific requirements of ETS on sociopragmatic assessment. But you see it's essentially a series of dialogues where you're choosing to make a comment. So here you'll see that there aren't any choices at the beginning, just to make sure that you understand the interface and you understand your goal. It's a kind of a tutorial level, if you will. And then as you continue, you walk around the environment answering some or having some more conversations. So you come across Mike, for example, and here you're having a conversation with Mike and you can say good morning, or you can say Mikey the muscle, or you could say there he's the one who puts the man in manager. You're trying to choose in this version of the game the most inappropriate response so that you can get the biggest rise out of people. And this is why we call it Awkward Annie. So you can see there's more and more of that. And the whole idea here is to sort of have fun in doing the sociopragmatics. Each response is animated to give you a little bit of a tight feedback loop to see how you're doing. So our main question here was basically, is it better to play badly or correctly? Sort of, do players prefer playing negatively or positively? And likewise, does that affect the evaluation? Does that affect the assessment? So you can think of player performance for affirming norms or breaking them. So something like Grand Theft Auto is largely about breaking norms, and then other games may be about affirming them. And the idea is also to figure out whether or not negative or positive systems would be better for assessment. So we have a negative version and a positive version, or affirming version and an opposite version. So you can think of it as sort of affirmative Annie and awkward Annie. So the research question number one was, how does the conversational goal, appropriate versus inappropriate, impact the user experience with an awkward Annie? And then question two was similar, with the idea that how does the conversation goal actually affect player performance? So we did a standard between subject study where we did pre-test. We actually had them play the game for about 20 minutes, and then we did a post-test. We had 350 English-speaking adult participants. They were largely, they all came from Mechanical Turk. And generally, their gender identity split fairly close to 50-50 male-female, with less than 1% responding as other or no response at all. And generally, our participant age is between 21 and 45. There were some outliers under 21 and above 46. Generally, everyone who played in this particular study saw 22 conversations across 5 different characters, 3 of which are shown here. We tried to design for a variety of sort of ethnic identities as well, and made sure it was gender mixed. And generally, it took about 20 minutes for people to complete the game. The results are as follows. So generally, in terms of pretest variables, what we were trying to do is just make sure that we could treat these results as equivalent in our between subject study. And so we basically found out that, and you can see this in the paper statistically, they can be. The appropriate people who play the appropriate version and people who play the inappropriate version were quite comparable. And so kind of highlighting our findings, you can see here that we've got self-report ratings about how amused, curious, engaged, or enjoyable the experience was. Likewise, whether or not they were interested in playing again, if they liked the play. And then we use some of the Csikszentmihalyi borders for things like anxiousness, boredom, confusion, embarrassment, and frustration. So of course we want to highlight that generally they are very close for inappropriate and appropriate, and you know, fluctuation between, say, amused in the inappropriate versus appropriate version and engaged, but the flip-flop was pretty minor. And then on the other side, as to whether or not people are interested in playing it, it's pretty even, especially on the play again factor, and it's dead even, almost dead even. And then on boredom, there was a little more boredom, marginally more boredom on the inappropriate version, which as a game designer surprised me because I expected that everybody wants to break rules, not conform to them. So also in terms of average self-reporting and performance or feeling about the pre-test and post-test, we have the same sort of like marginal differences. Unfortunately, you can see there's a big difference there in play-like, but I'll talk about that in a minute. So the core finding here, the core thing that we sort of want everyone to read and understand is that there is a game performance, almost a marginal, if not a lack of difference between performance in the appropriate and inappropriate version. So I actually gone into this research expecting that everybody wanted to play inappropriately because that was far more engaging than being told, congratulations, you're stopping at the stop signs and you're waiting at a red light. But it turns out with our study, what happened is you can see that the proportion of successful conversations is slightly, it's about the same with a slight margin toward appropriate. And then you can also see that the average conversation scores were close, although people actually outperformed slightly inappropriate versions. So this highlights the findings. Basically, players did not report any significant user experience differences between either one of the games, so appropriate or inappropriate. They were both sort of happy with either, but they actually performed significantly better in the appropriate version. So it's almost easier on the assessment side to give people the ability to say, stop at stop signs, make sure that you go on green, than the other. And we also see this in their performance. So if you would translate the way that they completed the assessment, the people who played the appropriate version got on average a 95% score, so almost 100. These are, again, people who've always spoken English. And then in appropriate version, you've got 84%. And roughly, although this is just quickly mentioned in the paper, people for whom English is a second language tended to score around 78 on this same assessment. And they were doing both the appropriate and inappropriate version, which we published in a different paper. So the whole finding here is that maybe being bad isn't always good, and that it's particularly true of assessment games, that when we're trying to assess quite complex things like sociopragmatics and pragmalinguistics, it might actually make sense to move towards the affirmative. And while players actually enjoyed both versions, they performed better in the appropriate version, and that's that key finding after 350 players. That's all I have. I hope I may be rushing through. I'd encourage people to catch the other papers as well, because I know we're running a little slow on time, but I'm happy to answer questions if you need me to.
Many thanks, and also thank you for being so considerate and being fast and leaving more room for Rogelio. So I'm looking at the chat. Do we have questions concerning this, this paper, which, allow me to remind you, is also not only an exceptional paper according to how it was rated by the readers, but also is a runner-up for the Best Paper Award for this year. So in case you like it, and in case you enjoy Lindsay's answers to your question, you can vote it using the conference system that Antonio suggested.
Vote Awkward Annie.
Vote Awkward Annie. Any takers for questions concerning this presentation? In case you have, you can unmute yourself. You're not limited in that right, and you can just speak and take the stage. I'll wait for a few more seconds. If I have no questions and no interrogatives, I will move on to the fourth paper for this session.
Yes, I put him to sleep.
Hello.
Oh, yeah.
Hello. Thank you very much for your very informative talk. I would like to ask if you taken into consideration the approach of players to wanting to explore the code itself. So choosing answers not exactly based on if they're appropriate or inappropriate, or what the game reaction will be and how this would affect your results.
Sure. So great question. Actually, if I understand it correctly, what you're asking is how much of playfulness is supported in this activity where people are simply trying to find the borders in social context?
Yeah, exactly.
Yeah.
In social context and in the game design itself, the game proper.
So we wrestled with that problem at the beginning. I created several prototypes that afforded for that. But one of the ways that we framed it is, hopefully at least, by, and I gave you a preview of it explicitly for this reason, the structure of the tutorial is actually designed to get you away from that thinking, to not think as playfully about it. And that's simply because we are still doing an assessment and we position as such. Usually in sort of future or questions about where this research is going forward, the ultimate goal is to produce something that substitutes for interviews, where someone who might be working for a corporation plays this game for 20 minutes and it's part of their assessments to see whether or not they are appropriate at being a Banana Republic employee in Tokyo.
Great, thank you.
Yeah, and actually you're on the Love and Affection book,
Yes.
right? You got the chapter
Yeah.
in it. So, hey, look, the plug for your work.
Yes. Finally, we meet each other, but virtually.
Yes.
We have room for one short question in case we have one.
I have one.
Edward.
Yeah, I was actually kind of curious if you thought the demographic of the population you tested, like specifically the age, might also account somewhat for the not liking to do socially unacceptable behavior in the game.
Absolutely. I have been frequently frustrated with the finding that time and time again, we seem to get better results from appropriateness. And I would love to run, I run it against a population of strictly self-identified gamers, because I think they're going to want to run the other way, which is one of the big ambiguities when you roll something out like this. But of course, the challenge is then we could also look at much smaller groups and we find idiosyncrasies there as well. So that's why I wanted a large set to find at least some version of a pattern. Looking to answer that question, is it easier to assess a game where you design it around appropriate or inappropriate behavior? I was really hoping it was inappropriate.
Thank you. That's really helpful. I'd love to see this with high schoolers, by the way. I think that'd be interesting.
Lindsay, thank you
guys.
for
Great questions.
Thank you for being so clear and so short and so thoughtful. We need to move on to the fourth paper for this track, which, as I mentioned already, is going to be commented by Sofia Eleni Spatariotti, but we have a video running soon. The presentation is a short one, and the title is Tyloscope AR, an augmented reality tabletop image labeling game toolkits. Quite a handful. Let's go, Phil.
Hi everyone, my name is Sofia Spatariotti, and today I'll be talking about Tyloscope AR, an augmented reality tabletop image labeling game toolkit. What is it?
Yeah, I think there's a delay with this video, with the video.
So we have another one of those situations. Is there any chance we can run Rogerio's in case you fixed it and then we go back?
I think Sophia is on standby, so she can do it.
Okay.
Can you?
Yeah, give me 1
screen?
second.
Sorry about this.
It's great. It's the first time we run online and 2 problems in the same track. Hooray. And we also had 3 full papers, which means that we had to run like the wind. And yet, great.
And have problems with the other tracks though.
Okay, so it's like a bias on my end to just think I'm being very unlucky. All right.
Some people are suggesting to play on other encoder. I can try. Let's see.
Thank you, Yone, for the comment. That's great.
Let's see.
Let's give it a shot.
Does this work?
Yes.
Can you see my screen?
Yes.
Yes.
Cool.
Try and press
Let's
play
see.
and see if it works.
Good luck to us.
Let's go. Unless we have no sound coming from you, at least I hear nothing. Can you try to share it with sound? There should be an option for that, Phil, if you could advise. We see the video, but there's no sound attached to it.
Let's see.
Yeah. So when you share, you can have the option to share without the audio.
So you need to first unshare and then reshare with the option that you did with sound.
Yes.
Okay.
Godspeed, Sophia.
Try now.
Hi Hi everyone, my name is Sophie Spathariotti, and today I'll be talking about Telescope-AR, an augmented reality tabletop image labeling game toolkit. Crowdsourced image labeling is often deployed when automated systems fail to provide reliable results. Two methods come to mind. One is the traditional approach, where you look at images one at a time and assign labels. And another thing that we can do is to add gaming elements. And one example here is the ESP game. There is, however, a third method, which is to get people together in a room to collectively look at images. Here you can see an example after Hurricane Harvey. For this work, we want to focus on this co-located in-person image labeling. And more specifically, we're interested in how can augmented reality and co-location enhance image labeling by fostering discussions. Social components have been linked to an increase in social outcomes, like broader sense of community and improvement in scientific literacy. Getting people together in a room to collaborate may not only increase the performance, but can also enhance long-term engagement with the project. AR can potentially offer a variety of benefits, from helping concepts memorize better to potentially achieving more effective collaboration than other digital or non-digital media. To this end, we developed Telescope-AR, an augmented reality image labeling toolkit. We utilize a physical component, which are the tiles that you can see on the right. These can vary, from simple paper printouts to more intricate pieces, using methods like laser cutting. Telescope-AR uses a bottom-up game design approach, where players can come up with different games and activities using the core image matching mechanics. Examples of collocation using physical components can be found in the domain of biology, chemistry, as well as animal identification. This is what Telescope-AR looks like in action. It is currently available on Android, and you can get it by going to cartoscode.pe/AR. More specifically, it works by hovering your camera over the tiles. The tiles will then appear as images on your phone screen. You can then select images you believe belong to the same category by pointing the phone over them and tapping the camera button once all images you want are visible. You will then receive audio and text feedback about the correctness of your match. Alternatively, you can also label one image at a time. A dialog box will appear with the available categories for you to choose. One question that arises here is, how do we go from image matching to image labeling? Well, we can achieve that by adding a subset of images for which we know the true category, the ground truth. This leads to three cases. We can make an incorrect match when we have at least two images with ground truth that don't agree with each other. We can make a correct match when we have only ground truth images of the same category. And finally, we can make a potential match when we have a mix of ground truth images of the same category and then some images with no ground truth. What happens here is that the images with no ground truth get assigned to the unique category. We conducted two studies using the AR toolkit. In the first, we asked participants to play memory competitively, then brainstorm new game ideas. For the second, we invited three groups to play three different activities. We used semi-structured interviews combined with observations, which were all coded using affinity diagrams. We also used the I My Enjoyment subskill. For our first study, which was small-scale and exploratory in nature, we recruited 14 participants, which were divided into groups of 2 or 4. We first asked them to play a round of memory competitively. We then asked them to brainstorm new game ideas using the toolkit, and finally we ended with an open-ended discussion. Observations and discussions were coded using affinity diagrams. We used two datasets for this study, one about animal identification from iNaturalist, and one about identifying flooded manure lagoon facilities after Hurricane Florence in 2018. Overflowed manure lagoons posed a serious environmental hazard in the area after the event. Our findings can be summarized in the following categories. We found that all groups started collaborating and discussing the images almost from the start, even if that meant they were effectively helping their opponents. When asked to come up with other games, participants suggested a variety of ideas, from adaptations to memory and existing games like Go Fish and Candy Crush, to completely novel ideas, complete with names and rules. Participants also suggested other applications for the toolkit, for education, monitoring, and further damage assessment. Finally, there were also comments about the tiles themselves. For example, we saw that some participants were stacking their tiles to show off how good they were. We also heard comments about how playing with the physical tiles can help people relax. For our second study, we used three activities: sorting with no game elements, memory, which is a competitive game, and a collaborative game we designed called TrekStack. We wanted to see how different groups would approach the toolkit and these activities. To this end, we recruited graduate students with a background in game design, faculty from the Social Sciences Department, and researchers from an Environmental Health Fellowship program, attending a bi-yearly conference off campus. We used the Hurricane Florence dataset for this study. Our collaborative game is played as follows. First, we deal one tile to the team and place the rest on a grid. Then, a pawn is placed on the bottom left corner, and the goal is for the pawn to reach the top right corner. Now the question is, how do we achieve that? We make moves by matching the team hand with tiles on the edges of the grid. If we are successful, we can slide the team hand in the grid, pushing the last tile out, which then becomes the new team hand. You can see here that we were able to move the pawn to the right this way. The team must then form a good strategy for reaching the top right corner. Looking at results from the IMI enjoyment subscale for each activity, as well as a ranking of all for enjoyment, we found that there was no one game fits all. Each group had a different preference for an activity. This suggests that having a customizable toolkit can serve multiple groups and backgrounds at the same time. More specifically, all groups approach the activities differently. The game designers preferred the most challenging activity. They approached memory competitively, and they were focused on winning and finishing the game. On the other hand, the sociology group preferred the least structured activity, which was sorting, and they did not enjoy the more complex game activities as much. Finally, the third group preferred memory the most, and they chose to perform every activity collaboratively. They also had the most discussions about the project overall. To summarize, we presented Telescope AR, an augmented reality toolkit for image labeling. We used the toolkit to explore how AR and collocation can enhance image labeling by fostering discussions, using 2 user studies. We found that overall, all participants started collaborating on images from the start, even if that meant that they were helping their opponents in competitive settings. We also observed exchanges of ideas about the images, suggesting that the toolkit can facilitate discussions about the projects. In our first study, we found that participants were able to suggest a variety of novel games. This indicates a potential for further adaptations of the toolkit. In our second study, we found that being able to support multiple activities can create equally engaging experiences for different groups. In terms of future work, we want to further mitigate behaviors of not using the app to verify matches. This happened in the second study for one group and one activity. We want to look into repeated use over longer periods of time, as well as to compare against a purely digital implementation. We want to thank all participants, and this work was supported by NSF and a Northeastern University Tier 1 grant. Thank you very much.
Thank you, Sophia. We managed to get to the end of the video. Very interesting stuff. Do we have questions? In case you do, please unmute yourself and just go ahead and ask. It appears like you convinced everybody, so Sophia.
I can also take questions on Discord to save some room for Rogerio.
That is very, very generous on your part. So unless we have any immediate requests for information and clarification, which I do not see, people are thanking you. Rogerio, thanks for acknowledging that. So I'm thinking we should move on. Thank you, everybody. And if you want to continue with FDG in room 1, there's a panel on narrative going on at the moment. Thank you, guys, and sorry for all the hiccups.